So, have you ever wondered if a river can get a fever? Well, today we're basically putting our planet's water on the examination table. We're going to figure out exactly how we measure its health, and more importantly, what we do when it gets sick.
All right, let's start with the big question that's going to guide us through this whole thing. How do you actually give water a health checkup? How do scientists walk up to a river or a lake and diagnose it?
Okay, so just like any good doctor, before we can even think about running tests, we have to understand the illness itself. What do we really mean when we say water is polluted?
Here's a really solid way to think about it. Water pollution is the loss of any of the actual or potential beneficial uses of water caused by any change due to human activity. The key things to grab onto there are loss of use and human activity. It just means the water can't do its job anymore, not for the ecosystem and not for us.
And this is absolutely crucial. It's all about concentration. A tiny, tiny bit of some substance might be totally fine, but when that same substance starts to build up, it just overwhelms the environment. It really is true that the dose makes the poison. So if our water is sick, what are the symptoms we should be looking for? And, maybe more importantly, what's causing the illness in the first place? Let's try and trace it back to the source. The problem really comes from two main places. First, you've got point source pollution. That's the easy one to spot. Think of a single pipe coming out of a factory. But then you have non-point source pollution, which is way, way trickier. It's that widespread runoff from, say, farms or city streets. It's like a death by 1,000 cuts. And what is actually in that pollution? Well, the list is surprisingly long. You've got the obvious stuff, right? Like organic waste and the nutrients that cause those awful algae blooms. Then there are nasty pesticides and heavy metals. But it even includes something you might not expect: heat. Yep, even just overly warm water can be a pollutant. All right, so we know the symptoms. Now it's time to head to the lab. How do scientists actually test the water to get a clear, undeniable diagnosis of its health? The very first and probably the most critical, vital sign they check is something called dissolved oxygen, or DO. The best way to think about it is this. Just like we need oxygen in the air to breathe, fish and all the other critters in the water need it dissolved in the water. If it's not there, the entire ecosystem basically suffocates. This chart here, it's basically a health report card for the water. If the DO level is up around 8 or 9 milligrams per liter, hey, it gets an A+. It's in great shape. But just look what happens as that number drops. The water's health reading just plummets, going from slightly to moderately, all the way down to gravely polluted. And right here, this is the critical tipping point. The moment dissolved oxygen drops below 5 milligrams per liter, it's a full-blown emergency. Aquatic life is put under incredible stress. Fish are literally struggling to breathe, and the whole ecosystem starts to collapse, right from the bottom up. So what's stealing all the oxygen? Well, the main culprit is organic waste. When stuff like sewage or farm runoff gets into the water, these huge armies of microorganisms wake up and get to work decomposing it. And just like us after a huge meal, they breathe really heavily, and in doing so, they consume a massive amount of dissolved oxygen. Now, to measure this oxygen-stealing effect, scientists use two key lab tests. The first one is called biochemical oxygen demand, or BOD. You can think of it as the all-you-can-eat buffet test. It measures how much oxygen those microbes will gobble up over 5 days as they just feast on all the biodegradable pollution. Then there's chemical oxygen demand, or COD. This is a much faster, more aggressive test. It measures the oxygen needed to break down everything, even the stuff the microbes can't eat. So if both of those numbers are high, you know you've got a seriously polluted body of water on your hands. Okay, so we've diagnosed the problem. We know the water is sick. We know why. So what's the treatment plan? How do we nurse it back to health? The recovery process for wastewater is usually this 3-stage journey. It starts with a big physical cleanup, then it moves to a biological deep clean, and it all ends with a final polishing. So primary treatment is basically physical triage for the water. First, these big screens act like bouncers at a club, blocking all the large objects like rags and plastics. Then the water flows into these quiet tanks, where gravity just takes over and all the heavy solids sink to the bottom as sludge. This simple step alone gets rid of a huge chunk of the pollution. Next up is secondary treatment, and this is where the real magic happens. We basically unleash our secret weapon, a massive army of helpful microorganisms. We create the perfect environment for them, bubbling tons of oxygen through the water, and in return, they just feast on all the dissolved pollutants. They're cleaning the water for us. And right before the treated water is released back into the environment, there's one last absolutely crucial safety check: disinfection. This step uses things like chlorine to kill off any dangerous disease-causing bacteria and viruses that might have somehow survived the first two stages. So, as we've seen, we have the science, we know how to diagnose sick water, and we have these incredibly effective treatments to cure it. So the real question isn't about the cure anymore, it's about prevention. If we know exactly what makes our water sick, what's stopping us from keeping it healthy from the start? Now that's the real challenge.